Next, we're going to talk about relations and implicitly defined functions. Okay? We talked about relations briefly when we talked about one-to-one functions. Remember we said a function, in a function you had to pass the vertical line test, or you had to pass the vertical line test. If you pass the vertical line test, it is a function. In other words, for every x, okay, for every x, you can only have one y, okay? Right. And we said that if you had things that do not pass the vertical line test, it is not a function, right? So if you had something like this, okay, for 1x, right here for 1x, you have 1, 2, 3 different y's, right? So this is obviously not a function. Okay, but it is something, right? And we called that something relations. We said it was relations. We said it was relations, right? And I think one of the examples that I gave was a circle, right? In a circle, you would have for every x, you would have 2 different y's, right? So you would have for every x, each x you had 2 different y's, right? So this is not a function, but I said it was a relation. Okay, so that's what a relation is. Okay, that's what a relation is. Okay, so let's go and see if we can do example number 6. So example number 6, and example number 6, you're gonna have what? Example number 6, we are to determine which of the ordered pairs 2 and negative 5, 1 and 3, 2 and 1 are in the relation defined by x squared y plus y squared is equal to 5, right? So we're trying to find this, okay? We're going to see if these points work. So we just go ahead and put them in, right? So for x, I get 2, so it'll be 4 times negative 5 plus negative 5 squared is going to be 25 is equal to 5. Does that work? This would be negative 20, well, so that works. So this guy is a winner, okay? So that guy works. Let's try 1 and 3. When x is 1 and y is 3, 3 squared is 9. This is going to be 12 is equal to 5. No, so this guy does not work. Okay, let's try 2 and, is it 11? 2 and 1, right? 2 and 1. 2 and 1, so I get 4 times 1 plus 4 here. Well, y is equal to 1, so the 1 squared is going to be 1 is equal to 5. 4 plus 1 is 5, so this guy works. This guy's another winner. So we have 2 different points that actually satisfy this relation. And is the relation a function? Well, is the relation a function? No, it's not, because for the same x equals 2, I have 2 different y's that work, right? So in other end, and that's definitely not a function, right? For every x, you can only have 1 y, okay? So this is not a function, this is a relation, okay? So then we're going to talk about, okay, implicitly defined functions. So we have, let's go back to the circle. X squared plus y squared is equal to 4. This is a circle with the origin as the center. And it is 2, negative 2, 2, negative 2, radius of 2. So this is your relation. It's a relation because it does not pass the horizontal line, the vertical line test, okay? If I were to, now most of our functions that we know are explicitly defined, right? Y is equal to x squared plus 2x plus 1. Y is equal to the absolute value of x. Y is equal to 4x minus 5. In other words, the x is explicitly specified for you. This is an explicitly defined function, okay? Whereas here, if you wanted to solve for y, you have to do some work. Okay, it's not there for you, so you're gonna have to say, okay, y squared is equal to 4 minus x squared. Y is equal to plus or minus square root of 4 minus x. There are two different functions, right? You have this function and you have this function. Okay, there are two different functions. If you graph this function, you're going to get this guy. Okay? If you graph this function, you're going to get this guy, the bottom part. Okay? So they separately view their functions. This is a function. This is a function. Okay? So if you superimpose the two, you get the circle. Okay? So this is an implicitly defined function, right? To find this was not given to you. You had to do some work. In other words, it is not in a form of y is equal to such and such and such. Okay, and that's what we call the implicitly defined function. Okay, so let's go to example number 7 and see if we can use this knowledge. Example number 7. Describe the graph of the relation, blah, blah, blah. So we have x squared plus 2xy plus y squared is equal to 1. Okay, well, just looking at this just looks kind of weird, right? I don't know what's going on. But if you can notice that this guy here is the same as this guy, now we have some hope. Okay? Because if x plus y squared is x squared plus 2xy plus y squared, right? Since I know this, now I can go like this, and I can say, well, x plus y is equal to, if I take the square root of both sides, I'm going to get that. Therefore, y is going to be equal to negative x plus or minus 1. Okay? So if I graph this, what do I get? If I graph this, these are two lines, right? There are two lines. Y is equal to negative x plus 1, negative x to minus 1. So if I graph those two lines, I'm going to get what? Y is equal to negative x plus 1, y is equal to negative x minus 1, 1 minus 1. Okay, so I'm going to get two parallel lines, right? Because the slopes are the same. They're both negative 1. We have two parallel lines there. Okay? And that is graphed in figure 1.61. Right. Any questions? Okay, if not, we're going to go ahead and call that a wrap.